Hello students, today we will be solving the IB Math AA Agent May 2023 paper 3 time zone 2 question number 2. You will be getting the link to the previously solved question of this paper, that is the question number 1 of this paper, and other solved questions of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. I'm Nilanjana Sanyal. I'm an online IB Math AA Agent level tutor. In case you are interested in joining my classes, you are seeing my phone number given and my website link given, so you may contact me for more details. So without any further delay, let us start answering this question number 2. The maximum mark is 31. This question asks you to examine linear and quadratic functions constructed in systematic ways using arithmetic sequences. Consider the function L of x equal to mx plus c, a linear function, for x belonging to the set of real numbers where m and c are also real numbers and m and c are not equal to 0. Let r belong to the set of real numbers be the root of L of x equal to 0. If m, r and c in that order are in arithmetic sequence, then L of x is said to be an AS linear function. Sapati's question is, show that L of x equal to 2x minus 1 is an AS linear function. So straight away, let me start my answer of Sapat A over here. So L of x equal to 2x minus 1, therefore, because we need the m, r and c, what is m? It is equal to 2. And c is equal to negative 1. Okay, so what is r? For that, we have to take Lx equal to 0, L of x equal to 0. So 2x minus 1 is equal to 0, implies x equal to half. This is equal to r. So I can write m, r and c. M is equal to 2, r equal to half and c equal to negative 1. We are seeing that half minus 2 is what? Which is negative 3 over 2 is equal to negative 1 minus half. I have taken the difference of these two and I have taken the difference of these two. Okay, to show that there exists a common difference between these numbers. So which is equal to D. Therefore, it is containing just 2 marks. Therefore, L of x equal to 2x minus 1 is an AS linear function. Okay. Okay, fine. So, shown. Okay. So, coming to subpart B, consider L of x equal to mx plus c. Now, m is a variable, c is also another variable. So, the gradient and the y-intercept, they are not constant numbers, no more. Subpart B is having 3 further subparts. First subpart I says, so that r equal to negative c over m. So, for that, the r is the root. So, L of x, let me write b and I. L of x equal to mx plus c equal to 0 gives us x equal to negative c over m, which is equal to r. Okay, this is shown. It is just containing a single mark. Okay, over here also, I have shown actually this. The working is over here, so I do not know which part to just box. So I'm leaving that sapati. Okay. And I, given that L of x is an ES linear function, show that L of x is equal to mx minus m square over m plus 2. It is containing 4 marks. Fine. Since L of s is an ES linear function, therefore m, r, and c are numbers from, and you write numbers, I have written as just numbers from an arithmetic sequence. See, L of x equal to mx plus c. So mx is staying. Only thing that we have to do is we have to prove that c is equal to negative m square over m plus 2. Okay. So we have already seen that r is equal to negative c over m. Okay. We know that r minus m is equal to c minus r. Okay. So we can write minus c over m. In place of r, I am writing minus c over m. Minus m is equal to c minus r. So it will be c plus c over m. Okay. And I need to get the value of c in terms of m because that is what is given to us. Okay. Now this is an equation which contains c and m. I have to make c the subject. That is all that I have to do now. So let me bring all the terms containing c to one side. So let me have this as c plus c over m, and plus c over m. This one is equal to negative m. I'm having negative sign over here. That is why I am keeping the negative m. Okay. And it is, if I take m common in the denominator, because I have to get m square, so I have to take m common. And c over m plus c over m is 2c over m. Okay, basically. So this is cm plus 2c is equal to m, negative m. Or it is cm, or I can take just c common. It is m plus 2 is equal to negative m square. Therefore, c is equal to negative m square over m plus 2. Okay. So, I hope you are being able to see this part. Yes. And therefore, let me write over here. Let me write the remaining one line. Therefore, L of x is equal to mx minus m square over m plus 2. This is this is shown. Okay, because I don't know whether if I write one more line below this, whether you will be able to see. Even now, I'm doubtful. I hope that you are being able to see this line. Okay. So, we have answered this. Oh, sorry, this is not subpart C. This is B and II. And III, the third subpart says, state any further restrictions on the value of m. Of course, we have the restriction because m plus 2 is in the denominator. Therefore, m cannot have a value of 2. And since it is carrying a single mark, I don't think that you have to give any justification for saying that m cannot have a value of 2. You just write that m is not equal to 2, or not 2, rather negative 2. Okay? Because if m is equal to negative 2 plus positive 2 added together will be giving us a 0 in the denominator, which we cannot have. Okay? So we have solved this part B, and then we come to the subpart C, which says there are only 3 integer sets of the values of m, r, and c that form an ES linear function. One of these is L of x equal to negative x negative 1. Negative x and negative 1, that means m is equal to negative 1 and c is equal to negative 1. And r was equal to negative c over m, so r is equal to 1 over negative 1. Okay, so it is equal to negative 1. So m equal to negative 1, c equal to negative 1, and r is also equal to negative 1. So this is one of the ES linear function. So you may say that then what is the common difference? The common difference is simply 0. Okay? So now coming to the subpart C's question, use subpart B to determine the other 2 ES linear functions with integer values of m, r, and c. It is containing 3 marks. You have to get 2 more functions of function expression for L of x, where you have to give specific numbers for m and c, because the L of x is having the expression mx plus c, so you have to get the numbers, numerical values for m and c, so that whatever root, whatever r value you get, m, r, and c, they form an arithmetic sequence. Okay, they are the 3 consecutive elements of an arithmetic sequence. Therefore, this is paper 3, we have to use the calculator, because if you just go on trying one by one, it will be taking a lot of time, obviously. And the question, this subpart contains 3 marks, so we just cannot afford to do this. And in case you do not know how to use the calculator, I am showing you how to use the calculator, but in case you see you get a question which you know that you have to use the calculator, but you are really not sure of how to use the calculator, I sincerely hope that you don't face such a situation. But in case it happens, then this question is containing 3 marks, carrying 3 marks. So I would suggest you to leave these 3 marks. Because if you try to get the values of m and c manually, because it is containing 3 marks, so you should not spend more than 3 or maximum or 4 minutes for this part, for answering this part. You have to get the values, you have to write the values. So everything done, including the reading of the question, should be done within 3 or maximum of 4 minutes. So obviously that cannot be done if you try to find the m and c values manually. So I would suggest you to just leave these 3 marks. Don't try to get the values manually, if in case you do not know how to use the calculator to get the values. Okay, so now m, let me write the subpart C's answer over here. M, r, and c. M we will be taking, we have to start with one of the numbers, so I'll be starting with m, and I'll be just taking different integer values of m, both positive and negative, not I, the calculator, and we will be finding for what integer values of m are we getting integer values of r and c. Okay, so let me write r. Okay, first of all, let me write the c's expression. So c is equal to negative m square over m plus 2. That we have found. So what was r? R was equal to negative c over m. So r is equal to negative, in place of c I am writing negative m square over m plus 2, and over m, so it is multiplied by 1 over m. So these two will be getting cancelled, and I will be having the r's expression as negative times negative is positive. So it is m over m plus 2. So I am having the variable m, and I am having the two other variables, the r and the c, expressed in terms of m. So practically I'm having only a single variable, because once I select one particular value of m, the values of r and c are just determined through the value of m. These are the dependent variables, only the m is the independent variable. So let us draw these two graphs. Okay, I'm using the TI Inspire calculator. I'm going to the add graphs, and first of all, I can draw any of them. Let me draw the C, because it is written above R. So let me take C first. So this, and okay, what happened? Yeah, m square. I'm not taking m square because it is a graph. I have to take x. So x square over x plus 2. Okay, fine. This is the graph. And the other one is x over x plus 2. X plus 2. Okay. Enter. Fine. This is the other one. I can take it over here. And what I have to do is I have to get the table. For that, I go to option number 7, table and split screen table. Over here, you may not be able to see the whole thing. So let me just bring it over here. Yes. So you see, x is the value of n. Instead of m, I have taken x. So these are the integer values you are seeing. Okay. And if I go up, I'll be having negative values as well. Okay. And f1x is the c, and f2x is the r. So we have to see for what values or what value of m are we getting some integer values for c and r, or r and c. One of them is, you are seeing, -1, -1 and -1. It has been given to us. We have to find two more. I am not seeing any of them over here. Let me go to the negative side. Let me see. No, no. -1, -1, -1. Okay. Okay. You see, when x is equal to -3, the c value, that means m is equal to -3, the c value is equal to 9, and the r value is equal to 3. When m is equal to -4, c is equal to 8, and the r is equal to 2. So we have to give the two cases. So we can write using GDC split screen tables. It is, we are having m, c and r, rather, because I have to give in this sequence. Okay, m, r and c, though I have inputted the c first anyway. When it is -3, the m value is -3, the r value is 3, and the c value is 9. Remember, the middle column is for c, the end column, right column, is for r. So when m is equal to -3, r is equal to +3, and c is equal to 9. So this is -3, 3, and 9. So you can see the difference, common difference is 6. So they indeed form an arithmetic sequence. And what is the other case? When m is equal to -4, r is equal to 2, and c is equal to 8. Okay, -4, 2, and 8. Okay, so over here you see 2 minus -4 is 6. So the common difference is 6, and 2 plus 6 is 8. So this is another arithmetic sequence. Okay, so therefore the other two is linear functions are L of x, this is 1, L of x equal to mx plus c. So minus 3x plus 9, and second one L of x equal to minus 4x plus 8. Okay, so these are the two answers for the support C. Okay. Consider the function q of x equal to ax square plus bx plus c. Now this is a quadratic function. For x belonging to the set of real numbers, a belongs to the set of real numbers, a is not equal to 0, and b and c also belong to the set of real numbers. Let r1 and r2 belonging to the set of real numbers be the roots of q of x equal to 0. Support D's question is write down an expression for, it is containing two further supports. Support I is sum of the roots R1 plus R2 in terms of A and B. So this is very easy. We write it as R1 plus R2 is equal to, they are containing just single marks. So equal to negative B over A, and R1, R2 equal to C over A. If A, R1, B, R2 and C in that order are in arithmetic sequence, then Q of x is said to be an AS quadratic function. Sapati's question is given that Q of x is an AS quadratic function. It is containing three further subparts. The first subpart I says write down an expression for R2 minus R1 in terms of A and B. Okay, so R2 minus R1. So we have to take a case where we will be having A, R1, B and R2. Okay, this part. A, R1, B and R2. And these four variables, they are the four consecutive elements of an arithmetic sequence. So there should be a common difference between them. So I can write, but I can write R1 minus A is equal to R2 minus B. So this gives us R2 minus R1 should be equal to B minus A. Okay, it is containing just a single mark. So this is justified. Do not go for solving the previous two equations that you have got, because it is in Sapadi. Do not just think that this is a continuation of that part and you get the expressions for R1 and R2 separately and then you subtract. Do not have to do so many things, and even then that will be containing the C. You don't have any C. You are not asked to get the C, include the C. You have to give the expression in terms of A and B, and it contains just a single mark. So that should be stopping you from going to that method. Okay. I. Use your answers to parse DI, that is DI was R1 plus R2 is equal to minus B over A. And EI, that is this, R2 minus R1. To show that So R1 equal to A square minus AB minus B over 2A. So now they have said how to get the expression for R1. Okay, so I can write this since this R2 is in front, so I can write this R2 plus R1 is equal to negative B over A, and R2 minus R1 is equal to B minus A. Okay. And now since if I add, I'll be losing the R1. I need the R1, so I'll be subtracting. So I have to change the signs. This will be minus and this will be plus. And now these two will be getting cancelled. We have 2R1 equal to negative B over A minus B plus A. Okay, and I'm having A in the denominator. So let us make A the common denominator. So it will be A negative B and negative AB plus A square. Okay, therefore R1 is equal to A square minus AB minus B over 2A. So this is shown. Okay. I. Use the result from part EII, that is this one, to show that B is equal to 0 or equal to negative half. It is containing 3 marks. And they have asked us to use this. It is fine that we will be using that expression, but we have to, since we have to get numerical values of B and A, therefore we have to have some equation. Okay, if we don't have any equation, this is just an expression of R1. In order to solve some equation, not an equation, means in order to get a numerical value of a variable, we need to have an equation, and after solving that equation, we will be getting the numerical value of the variable used in the equation. Okay, that is the general process. So, what can we take as the equation? Since we are having the expression R1 equal to, I'm saying all these because I could have just solved the question, but I'm saying these things just to make you think that how will you be coming to that equation? How will you be forming that equation? Since you are having R1 equal to some expression, so if I get another expression for R1, then we can equate these two expressions and then we can try to get the values. You may say that there are two variables and uh, a single equation. How can we get the values of both the variables? Okay, let us at least try to get a single variable's value if possible. But at least, first of all, we have to form an equation. So let us try to form an equation. Okay. So let me write it over here. I'm not sure whether I'll be able to fit in, or I can go down. Yeah. So, yeah, then I can start writing over here. So, what is the other expression that I can take for R1? See, A, R1 and B. I am taking this part, A, R1 and B, because R1, A and B, this equation contains R1, A and B. Therefore, I am taking again A, R1 and B. Okay, these three elements of the arithmetic sequence. And I can write R1 minus A is equal to B minus R1. So, R1 minus A is equal to B minus R1. Okay. So, 2R1 is equal to A plus B, or R1 is equal to A plus B over 2. Okay. And we are having this expression of R1. So, I'll be equating these two. So, I can write, therefore, A square minus AB minus B over 2A is equal to A plus B over 2. These two 2's will be getting cancelled and we will be having, I'm multiplying this A and this A plus B, so it is A square plus AB. That means I'm multiplying the entire equation by A. Okay? A square plus AB is equal to A square minus AB minus B. So these two will be getting cancelled again. This means that I'm subtracting A square from both the sides of the equal to sign. And then I can write this as 2AB plus B is equal to 0 and equal to 0, and if I take the B, the common factor out, it will be B times 2A plus 1 equal to 0. So either B will be equal to 0 or 2A plus 1 will be equal to 0. Therefore, B is equal to 0, or if 2A plus 1 is equal to 0, A will be equal to negative half. So these are the values that have been given to us. See, B equal to 0 or A equal to negative half. 3 marks. We have got 3 marks. Now consider the case where B is equal to 0. Subpart F. Determine two A's quadratic functions that satisfy this condition. It is containing 5 marks. Okay. So, let us start my answer for subpart A over F over here. Okay. P is equal to 0. This is a quadratic function. So, Q of x. Now, Q of x, since B is equal to 0, it will be equal to ax squared plus c. Okay. So, therefore, R1 plus R2 is equal to 0, which says that R2 is equal to negative R1. Okay. And since I have taken R1 plus R2, actually there are several methods of solving this question. So whichever step is coming to my mind, I'm just writing it. And R1 times R2 is equal to C over A. Okay. So C over A, and it is R1 times R2, and since R2 is equal to negative R1, so this is equal to R1 times negative R1, which is equal to negative R1 square. Okay, so negative R1 square is equal to C over E. And now let me see what is the value of R1, because we have got this expression for R1 using R1 is equal to A square minus AB minus B over 2A. Since B is equal to 0, therefore R1 is equal to, this is 0, this is 0, so A square over 2A. So it will be A over 2, okay? So it is A over 2. And obviously R2 is equal to negative A over 2. Therefore, I can say that C over E is equal to negative R1. Therefore, C over A is equal to negative R1 square is equal to negative A over 2 whole square, which is equal to negative A square over 4. This says that C is equal to negative A cube over 4. Okay? Fine. Therefore, Q of x is equal to ax square and minus a cube over 4. But what is the value of a? Because I have to get the numerical coefficients. I cannot keep that as ax square minus a cube over 4. I cannot keep that. Okay. So what can be done? So somehow we have to get the value of a. Just like I had done in the previous subpart of E, the final subpart, I had equated two expressions for R1. can I do the same thing over here? Like one of the expressions for C is this, minus a cube over 4. Can I get some other expression for C? Let's see. If I go up, you see A, R1, B, R2, and C, these are the elements of an arithmetic sequence. So, A is the first term, R1 is the second, B is the third, R2 is the fourth, and C is the fifth term. So, C can be written as A plus 4D, where D is the common difference. Okay. So if I can get the value of D in terms of A, then I will be having another expression for C in terms of A. Then I can equate these two to get the value of A. Because I have to get the value of A somehow. Okay. So I am seeing that C is equal to A plus 40. C is equal to A plus 40. Okay. And also D is equal to R1 minus A. Okay. So R1 is what? A over 2. So this is equal to A over 2 minus A, which is equal to negative A over 2. Okay. Therefore, C is equal to A plus 4 times negative A over 2. These two will be getting cancelled. So it is A minus 2A, which is equal to negative A. So once we have got the C's expression as negative A cube over 4, another time we are getting the C's expression as negative A. So let us equate these two. Okay. So therefore, negative A cube over 4 is equal to negative A. And I can cancel these two negative signs. So I get A cube is equal to 4A, or A cube minus 4A is equal to 0. Therefore, A and A square minus 4 is equal to 0. Since A is not equal to 0, they have mentioned at the very first moment when they have defined the Q of X expression, Ax square plus Bx plus C. A is not equal to 0. So A is not equal to 0. Therefore, A square minus 4 has to be equal to 0. Therefore, A is equal to plus minus 2. Okay. So as soon as I am getting A value as either plus 2 or minus 2, what will be the C value? If A is equal to plus 2, C will be negative 2. If A is negative 2, C will be positive 2. And if you say that, okay, this is the expression for C equal to negative A you are taking. What if you take this expression, C equal to negative A cube over 4? Let's see. From this expression, we are seeing, from this equation, we are seeing when E equal to plus 2, C should be having the value of negative 2. And let us come over here. We have taken the value of A as positive 2. So 2 cube is 8, 8 over 4 is 2, and there is the minus sign in front, so C equal to negative. And if A equal to negative 2, what happens? Negative 2 whole cube is negative 8. Divided by 4 is negative 2. There is a minus sign in front, so it becomes positive 2. Doesn't matter which expression for C you are taking, you will be getting the same value for C. Okay? Therefore, we can, using this, we can also write that Q of X is equal to AX minus A. Okay? Because C equal to minus A. I have written this expression using this expression for C. Now I am writing this using this expression for C. So when A equal to 2, Q of X is equal to 2x minus 2. When, or I can put a full stop, when A equal to negative 2, Q of X is equal to negative 2x plus 2. So these are the two is quadratic functions. Okay. Fine. Now consider the case where A equal to negative half. Subpart G containing two further subparts. Subpart I is saying find an expression for R1 in terms of B. So we are having this expression for R1. I'll be just plugging in the value of negative half wherever I am having a in the expression. So R1 is equal to negative half whole square minus negative half b minus b over 2 times negative half. Okay, so this is equal to 1 over 4. Negative half whole square is 1 over 4, and this is plus half b or b over 2 minus b over 2 times negative half is negative 1. And b over 2 minus b is equal to negative b over 2. So it is, and there's the minus sign, minus 1 in the denominator. So I can just write negative 1 over 4. And this is negative b over 2 divided by negative 1. So it is plus b over 2. Okay. So this is the value for R1, or the expression for R1 in terms of b. You can of course write the b over 2 as the first term. You can write this in this form also. Okay. Or else you can make the common denominator as 4. You can do all sorts of modification, but even if you keep it in this way, you are absolutely correct and you get marks. Okay. Sapat I hence, or otherwise you may take the help of the previous Sapat, or else you may use other method also. Determine the exact values of b and c such that A's quadratic functions are formed. Okay. A's quadratic functions means A, R1, B, R2, and C, they form an arithmetic sequence. Okay. And give your answers in the form for B and C minus P plus minus Q times root S over 2, where P, Q, and S belong to the set of positive integers. It is containing 5 marks. Okay, so fine. So I can say the Q of X is now, at least we know the value of A, so it is negative half X squared plus Bx plus C. Okay, since we know the expression for R1, let us start with R1. Okay, not do I start with R1, I am starting with the expression R1 plus R2. That is equal to negative B over A. And A is equal to negative half. So at least I'm eliminating one of the variables and I'll be getting the expression for R1 plus R2 in terms of B, only B. So it is negative half over negative B over negative half. So the negative signs will be getting cancelled and we will be having R1 plus R2 is equal to 2B. Okay, so therefore, I can write R2 equal to 2B minus R1. And what is R1? R1 is this. So I'm trying to find the expression for R2 also in terms of B. I'm really not sure at this stage if I'll be needing this or not. Let's see. So 2B minus B over 2 plus half. Not half, 1/4. And 2B minus B over 2 is 1.5B. So this is equal to 3 over 2B or 3B over 2 plus 1/4. Okay, so this is the expression for R2. I'm just underlining this because this is not the answer. So this one, I'm solving the I part. This is the expression for R2. And fine. So if I try to get R1 times R2, it will be C over A. And I know A is equal to negative half. So it will be negative 2C. That is fine. But I'm getting another variable as C. Till now, I'm using only a single variable B. I don't want to bring another variable C. First of all, let me get the expression for B. So what I can do is I can try to get the common difference. Okay. What is the common difference? The common difference, what is R1? R1 is equal to A plus D. Okay. And R2 is equal to A, since this is the fourth term, it is A plus 3D. Yes, of course, A is equal to negative half. I'm not taking, I'm not putting the value because ultimately it will be getting cancelled. So I am seeing that R2 minus R1 is equal to A plus 3D minus A plus D, which is equal to 2D. Okay. And what is R2? So let me try to find the value of D in terms of B. Okay. So 2D is equal to, I'm substituting the expression for R2, 3B over 2 plus 1/4 minus R1. R1 is this. So minus R1, so it will be plus 1/4 and minus B over 2. So this is equal to 1.5 B minus half B is 1 B. So it is B, and 1/4 plus 1/4 is 2 over 4, which is half. Therefore, D is equal to B over 2 plus 1 over 4. Okay. So this is the expression for D in terms of B. And whatever I'm getting, I'm trying to get the expression in terms of B so that I have to deal with a single variable. Okay. And now I have seen that C is equal to A plus 40 because it is A, R1, B, R2 and C. So C is equal to A plus 40. Therefore, C is equal to A plus 4D equal to A is equal to negative half plus 4 times D is this, B over 2 plus 1 over 4. Okay. So this is equal to negative half and this is plus 2B and this one is plus 1. And 1 minus half is half. So it is 2B plus half. This is the expression for C in terms of B. Now I have got everything in terms of B, so I can hope for getting a numerical value of B, but I have to form an equation for that. So therefore, I am writing R1 times R2 should be equal to C over E. Okay. So what is R1? I'm substituting the expression for R1. It is B over 2 minus 1 over 4 and R2 is equal to 3B over 2 plus 1/4. This is equal to C over A. C is equal to this. 2B plus half over A means divided by A. A is equal to negative half. So divided by negative half. Okay. So this is B over 2 times 3B over 2 is 3B square over 4. And B over 2 times 1 over 4 is plus B over 8. Negative 1 over 4 times 3B over 2 is negative 3B over 8. And negative 1 over 4 times by positive 1 over 4 is negative 1 over 16. Okay. So this is the left hand side, and divided by negative half is in fact equivalent to multiplying by negative 2. Okay. So this is 2 multiplied by 2B is equal to 4B, and negative 2 multiplied by half is negative 1. Negative 2 multiplied by 2B is equal to negative 4B, and negative 2 multiplied by half is negative 1. Okay. So now we have got an equation which contains only this variable B. So definitely we can think of getting the value of B. So it is another thing that I can do is I'm having the denominator of 4, 8 and 16. So let us make the common denominator as 16. Okay. So for the first term, it is 4 times 4 is 16. So it is 4 times 3 is 12, 12b square. And 8 times 2 is 16. So it is plus 2b. And minus 6b and minus 1 divided by 16. So I am just taking 16 to the other side. Minus 4b minus 1. So this is equal to minus 64b minus 16. Okay. So if I simplify this, what happens? 12b square stays, and 2b minus 6b is minus 4b. And from here we are having, if I take minus 64b to the left side, it is plus 64b minus 4b, which is plus 60b. And there is this minus 1 and there is this minus 16. If taken to the other side, it is 16. 16 minus 1 is plus 50. Okay. If we just try to reduce the numbers, what happens? I can divide the entire equation by 4, rather 3. So I can get 4b square plus 20b plus 5 equal to 0. Okay. So therefore, I'll be using the quadratic formula. Now, the variable is b. Don't get confused. For the using the quadratic formula, it is x equal to negative b plus minus square root of b square. Don't confuse that b with this b. Over here, this b stands for the x. So don't get confused. So I'm writing b equal to negative b. Negative b is the coefficient, negative of the coefficient of the term containing the variable raised to the power of 1, which is this 20. The coefficient is 20. So negative of that is negative 20 plus minus square root b square. 20 square is 400 minus 4ac. 4 times, I'm multiplying this first. The 5, 4 times 5 is 20. 20 times 4 is 80. Because otherwise, if you multiply 4 times 4, 16. 16 times 5, maybe some of you have to do the calculation with pen and paper. But if you multiply 4 times 5, it is 20. 20 times 4, you get it as 80 easily. Okay. So this is minus 80 over 2a. Now, you see, they have kept the denominator as 2. Therefore, I am keeping the 2a as 2 times 4. I just don't want to multiply because I have to know, I have to remember that I have to keep that 2. Okay. So, and 400 minus 80 is of course equal to 320. And fine. So, minus 20 plus minus root 320. So, what is 320 root? Let me get the factors, prime factors of 320. Or, okay, if you use a calculator, you will be getting in decimals, but they are asking for the exact value. So, you have to get the prime factors of 320. So, it is 160, then 80, then 40, 20, 10, 5. Okay. So you are having 1, 2, 3, 4, 5, 6 twos and 1 5. Since it is the square root, you have to pair them. I'm taking this pair, and this pair. So I'll be taking out 1, 2 from each pair. So it is 2 times 2 times 2. It is 8. So it is 8 root 5. This is how you have to do the square root to get the exact square root. Okay. Simplified form, in a simplified form. Okay. So this is this. And then I can just separate, I can not separate, but I can divide the numerator by 4 because I have to keep 2 in the denominator. So I can divide the numerator by 4 and of course the denominator also by 4. So this 4 goes. So negative 20 over 4 is negative 5 and plus minus 8 over 4 is 2. So it is 2 root 5 over 2. So this is the value of expression for b. I hope that you are being able to see. Okay, and then we have got the expression for B, so now we come to the C part. And C was having this expression, 2B plus half. Okay, so let me write this expression once more. 2B plus half equal to 2 times negative 5 plus minus 2 root 5 over 2 plus half. These two will be getting cancelled, and you have this as minus 5 plus minus 2 root 5 and plus half, and minus 5 plus half is negative 4 and a half, which is negative 9 over 2. So you can write this as negative 9 over 2. Okay, so negative 9 over 2 plus minus 2 root 5. And again, they have asked for a common denominator of 2. This is having a denominator of 2, but this is not having. So I have to manipulate. I can write this 2 as 4 over 2 because I need the denominator as 2. So C is equal to minus 9 plus minus 4 root 5 over 2. Okay. So it is minus 9 over 2 and 4 over 2 gives us the 2. This you have to understand because you have to give the answer in the format that they have asked for. So we have completed answering this question totally. Question number 2 and of paper 3. So from our next session, we go to the November 2023 papers. Thank you for staying with me till the end. And please like this video if you liked my explanation. And please do share this video with your friends so that even they can get benefited by watching my videos. Please subscribe to my YouTube channel so that the YouTube channel understands that my videos are worth watching, so that it shows my videos to other students also, and they will also be getting benefited by watching my video in turn. So actively, or sorry, rather passively, you will be helping other students. And in case you are having any doubt, any confusion, please feel free to write to me in the comments section. I'll be answering your doubts as much as possible. We meet again very soon in our next session. As I've said, we will be starting with the November 2023 paper 1. Till then, bye.